Hi there, my name's Dan Westgate from Brilliant Ideas, and the purpose of this video is to actually talk about the load effect that a machine like this would have in the tracking and operating condition. And we get a lot of inquiries at Brilliant Ideas for load spread solutions utilising our modular aluminium outrigger load spread system, ALIMATS, and often that is for the operating condition only. What I'm going to quickly talk about is the tracking condition. Now, currently, these tracks are actually extended out to 1.1 metres wide. In the closed condition, they're 750 mil wide. Now, the contact length of this track is 1 metre, and the width of the track is 180 millimetres. So clearly, the tracks are putting quite a concentration of load down in the tracking condition compared to the outriggers that, when they're deployed, at roughly 2.8 metre centres. In the operating condition, when the basket is extended, it's putting a concentration of load on certain corners. You can get that information of exactly what that load would be from the operator's manual, but that information is not always forthcoming when these load assessments are being carried out prior to arrival to site. So some approaches would be to adopt the 60% rule, which is to take 60% of the machine weight and then add the basket weight as well. Now, based on the 60% rule, the load going through a single outrigger foot would be in the region of about 1.4 tonnes. Therefore, in most cases, load spread solutions would be required. If you adopted a more conservative approach of the 75% rule, your actual load going through one of the single outriggers would be in order of 1.7 tonnes. Now, it's not as simple as this, but globally, when the tracks are off the ground, the actual load on average would be about 550 kgs per outrigger foot, still a considerable force. We've got the MEWP spider MEWP tracking across aluminium platform made of ALIMAT modules. These particular modules are 1.16 by 0.58 wide. The contact length of these tracks is 1 metre and the width of the tracks is 0.18 wide. You can see the track is in contact with 2 mats at any given time, and on occasion it's in contact with 3. 2 tracks would provide a load spread in the tracking condition of 1.34 metres squared, and actually you can see when we're in contact with more, you're actually getting upwards of nearly 2.01. You can see our 2 operatives here. They're using the track as a rolling road to keep the costs down and also the sustainability side of transport. The modules at the back of this will also be used for the operating condition when the outriggers are deployed. We've already set up 3 of the outrigger mats using our 2.01 metre square configuration, which is 2 standard mats on the base layer, each being 1.74 metres by 0.58 metres wide. So overall, you get 1.74 by 1.16 metres, which gives you 2.01 metres squared load spread. And then the top layer is the short modules, which are 1.16 by 0.58, and in a pair, that is 1.34 metres squared. And then we've just got the top pad, which is a 600 square nylon Nylacast pad, 40 mil thick. We've actually used the rolling road mats for the top layer, so we only need 8 additional mats for the outrigger mats. All aluminium modules in the ALIMAT range are all handleable, and one of the benefits of the interlock is structural, but the other one is operational, where the mats don't pull apart during setup underneath the outrigger. Mat configurations do come in a vast range, from the mini mat working singly on its own all the way up to 8.07 metre square configurations for outriggers. But then we've also got multiple applications for powered access machines where we can come up with solutions for both tracking and operating conditions. So you can see the outriggers have been deployed. Obviously, you've had the tracking mats support it in the tracking and stationary condition. And now we've got the outrigger mats underneath the outriggers, spreading the load ready for the operating condition.